Number 5. Use the following function to answer parts A through C. So the function is f of x equals 2x to the third plus 6x to the second plus 5x plus 2. First, they want us to list the possible rational roots. So that's going to be the factors of 2 over the factors of 2, plus or minus 1 plus or minus 2 over plus or minus 1 plus or minus 2. So the first time they'll be over 1, so they'll be plus or minus 1 plus or minus 2. And then when we put them over 2, plus or minus 1 over 2 plus or minus 2 over 2. And this reduces down to 1, so these are the 6 possible rational roots. Plus or minus 1, plus or minus 2, plus or minus 1/2. Now in part B, they ask us to use synthetic division to find if any of these are actually zeros of the function. That means when we synthetically divide, we'll get a 0 remainder. So I start with 1, and I put the coefficients of my polynomial inside, and notice that the polynomial is in standard form and all exponents are represented. I drop down the 2, and then I multiply and add. 1 times 2 is 2, 6 plus 2 is 8. 1 times 8 is 8, 5 plus 8 is 13. 1 times 13 is 13, 2 plus 13 is 15, not 0, not a root or 0 of the function. Try -1. 2, 6, 5, and 2 on the inside. The first 2 drops down. -1 times 2 is -2, add I get 4. -1 times 4 is -4, add I get 1. -1 times 1 is -1, add I get 1. That is also not a 0. Divide by the next one, +2. And you can go in any order you like. I usually just go in order from smallest to largest. On the inside, 2, 6, 5, and 2. The 2 drops down. Then I multiply. 2 times 2 is 4. 6 and 4 is 10. 2 times 2 is 20. 20 and 5 is 25. 2 times 25 is 50. 2 and 50 is 52. That's not 0, so that's not a 0 of the function. -2. On the outside, 2, 6, 5, and 2 on the inside. 2 drops down. -2 times 2 is -4. Add I get 2. -2 times 2 is -4 again. Add I get 1. -2 times 1 is -2. Add I get 0. Therefore, yes, this is a 0 of the function. Now remember that if -2 is a 0, x plus 2 is a factor, and this trinomial becomes 2x squared plus 2x plus 1. It's the coefficients of a trinomial starting with 1 degree lower than the original. So now I have to deal with this second factor. It's a trinomial with an x squared, and so I could factor it if possible. I could use synthetic division on it, or I could use the quadratic formula. And I think that's what I'm going to do, is I'm going to use the quadratic formula. So x is the opposite of b plus or minus the square root of b squared minus 4ac. All of that is over 2 times a. And I opted for the quadratic formula because it will always work for a quadratic equation, whereas synthetic division, you don't know if you're going to get something that works or not, and factoring you have to play around with to see if it'll even factor. This is a fail-safe method, and so anytime I have a trinomial that I don't see the factoring immediately, I just go ahead and use a quadratic formula. So my a is 2, my b is 2, and my c is 1. So plugging those in, I get x is the opposite of 2, negative 2, plus or minus the square root. So that's 2 squared, which is 4, minus 4 times 2 times 1, and that's all over 2 times 2. And so I get negative 2 plus or minus the square root of 4 minus 8 over 4, and that's negative 2 plus or minus the square root of negative 4 over 4. Now this is not a real number, and you'll notice they ask us in part C just to list the real zeros. Remember, real zeros equal x-intercepts. And for this function, we know that x equals negative 2 is a real zero, and these are going to be complex, okay, because they're going to have an I in them. Remember, take the square root of negative, you have to put an I. So let me go ahead and simplify that the way we would, just so you can see it. That's going to be a 2i, and all of that is over 4. And I would need to split this apart with both parts over the 4 and reduce it to negative 1/2 plus or minus 1/2 I. Now these are conjugate complex roots, okay? Remember, they come in pairs because of the plus and minus, and they will not be an x-intercept. Now I want to show you in Desmos what this means. So I've typed my function into the Desmos graphing calculator, and you'll see right here at the negative 2 that we have an x-intercept. But notice how this function is above the x-axis instead of crossing it again. So that's what the nature of those imaginary roots will do to the graph. They'll only cross at the real zeros, and if there's a complex zero, if you have a low point like this, it's going to occur up here above the x-axis.